Hey, we're back after a busy week. Ray suggested that I increase the UI scale. Great tip. I hope you can see it a little bit better now. This is where we left off. I want to show you something really quick. I will instance this little arrow that I made just to show you this is what we've been working on. All of these nodes that we just did here are simply here to get a point grid where every point has a specific direction that we decided on. Don't get distracted by all the fancy geometry and windows from our little cube here. This is the heart of it. And actually, the only node that adds the building-like detail is this point instance node, because it takes this point and puts this cube here. I think that's just important to keep in mind, just to keep understanding what we're doing here. And now we have points in these corners already, otherwise they would be empty, which is excellent. We don't need to add any new points here. We simply just have to replace the points that are in the corners with another model. We can get another model by getting another point instance node. And let's get something easily distinguishable like a UV sphere. And like I did with the cube, I'm going to scale it down by half, move it up half a meter, and I'm going to sample it in this instance node. Now, if I give it the same geometry and put it in here, you can see, well, spheres. But we want only some of these points to be spheres. There's this node called point separate, which does exactly what we need. It takes one geometry input and two geometry outputs, and whatever we put in the mask separates the geometry into two. So I'm going to take geometry 2 and plug it into the sphere. Well, this point separate node takes this weird blue input, and those are attributes. So let's maybe take an attribute randomize node just to show you what we are doing. And if I now plug in a value, for example, R&D for random, it creates this new attribute called R&D, which I now can copy over here as a mask. Now everything disappeared, but if I lower this min value, you can kind of see, okay, I'm getting random blocks here and I've punched out these holes. The reason they are holes, because we just have this point instance connected, and this one, which contains the other half of the puzzle, is not connected anywhere. So under geometry, you can find join geometry, and if I now join them together, you get the big picture. However, we don't just want random balls in here. We want our spheres, or well, later on our corner model, just in the corners. So let's get rid of this attribute randomize node. Let's give the mask a nicer name, something like corners, and instead add a attribute separate XYZ node here. So each and every point comes with a couple standard values. There is a rotation attribute, which, well, records the rotation of a point, and most importantly, there's a position attribute, which just for every point contains a little bit of information where this point is. For example, this point could be at 1, 5, 0, which would be x, y, and z axis values. And every point has this value without us needing to do anything. And this value is an attribute called position. And you will always find it, and it's going to be suggested to you. And we can just put it here into vector. These corners are special in the sense that their position is always at the most outer value. It is easier to think about these position values in 3 separate axes rather than one vector. So I'm going to separate this position vector that comes with every point, and I'm going to separate it into the x, y, and z axis. And I'm going to create new attributes, pos x for position x, pos y, and pos z. And now every point here has an attribute pos x that tells me where on the x-axis this point is. Now from this position x value, I somehow want to get a corner mask. And one of the ways to do it is taking a attribute compare node. An attribute compare node takes two inputs, A and B, compares them with each other, and gives me a result. So I'm going to compare my position x value with, well, not an attribute because I don't have an attribute to compare it with, but I'm going to select a float, which is going to change this input to a float value. And the result of this comparison, I'm going to put into the corners mask. So I'm going to type in corners. And now you will see that our object has split in half. this is where the value 0 would be on the x-axis. This is 1, 2, 3, 4, 5. This is -1, -2, 3, 4, 5. And now we took everything that is greater than 0, every position on the x-axis that is greater than 0, and turned it into the sphere by splitting it with a point separate node. So now changing this value lets me dial in those outer walls. And you might already guessed it, we now want to connect this value with one of our geometry nodes input. So let's check it out. That's the wrong one. All right, that's the right one. As you can see, when our building gets wider, we need to adjust this B value. So instead of grabbing this value all the way over here and rerouting it, I'm just going to do the following trick, which I unfortunately just discovered relatively late in my other build. We can just take another group input, which is a duplicate of this one, but we can just take the width from here and plug it in. Now we just have to do the correct math again, so we just think about what we did before and just try dividing it by 2 again and see what happens. Right, let me adjust the value, and as you can see, that was apparently the right operation, though now we just have to add or subtract something again. So let's duplicate this math node. I'll subtract 1, and that was the wrong operation, so I'll add 1, and now we're good. So we got one wall now, but we want the corner. Well, now if you imagine that we had this wall as well, and we had an attribute that describes this wall, we just had to figure out which of all these blocks are part of this and that wall, and those would just be the corners left over. So let's just do the boring thing and declare the other walls as well. I'm going to go on my top view and just figure out, okay, this is what I will call the right wall. So instead of corners, I'm going to write in right wall. Wonderful. This is now our right wall. Let's do the same thing again. I'm going to duplicate the attribute compare node. So now let's change this result back to corners, which is, well, essentially just like my preview, so I can see what I'm doing. And instead of greater than, let's try less than, which flips around this constellation. And if I now add in a value that is negative, I get the other wall. So let's try to duplicate those nodes here with Shift-Control-D. I'm maintaining this location. I'm going to plug in the value here, and let's try dividing it by -2, which should flip around the result. And now instead of adding 1, we apparently can just get rid of this node. You can check it out quite easily by just pressing M to mute a node. So Control-X should dissolve it, which is just taking it out of the equation. And now we got the other wall, which 7 tells me it's the left wall. Left wall. So with the left and the right wall done, we now just need to do the same thing for the top and the bottom wall, and it just works exactly the same. But instead of comparing the position X value, I'm going to duplicate it and type in position Y. And yet again, instead of left wall, I'm going to type in corners so I can see what I'm doing. And now if I switch this value, yeah, you can see we can dial in this wall. So let's do just that. I'm going to duplicate this divide by -2 node, and now we're going to need the depth this time because we changed the axis and we're now looking at the y-axis. I'll plug in this divide node here, and I think we have to do some addition perhaps. Let's add 1. Seems to work out. And this would be the bottom wall. Bottom wall. And now, last but not least, the same thing a 4th time. We are going to switch back to greater than. We are going to keep position Y, but I'm going to rename it to corners again, so we can see what we're doing. Duplicate the divide, plug it in, change it to 2 instead of -2. Seems like it worked again, but we need yet another add node perhaps, and this time we need to add 2, as it seems. So instead of corners, now this should be the top wall. So I admit it's getting a little bit more complicated and convoluted right now because we're talking about attributes. What we essentially just did is we just put each wall into a different group. Like the bottom wall is now referenced by this attribute that we called bottom wall. And the reason why, even though we added a whole bunch of nodes, we don't see a difference yet, because we just have declared the attributes. We haven't used them though. But that's going to change now. I'm going to get an attribute math node. And as factor A, I'm going to get top wall. And as factor B, I'm going to get the right wall. Which ones you choose and in which order isn't that important. What's important is that those two walls are connected. So top wall and right wall have this connection here. If I would have typed in top wall and bottom wall, we could not essentially not compare them because they have no intersections with each other. And as a result, I'm going to type in corners again so we can see what we're doing. If we now choose multiply, you can see that we got this very corner. And now, well, you already guessed it, we have to do the same thing 4 times again. Though we have to do something a little different now, I'm going to duplicate this math node, and instead of corners, I'm going to type in something temporary. Just it doesn't matter what. Let's just call it, I'm just going to call it temp for temporary. And I'm going to use a add operation. And I'm going to take corners. And I'm going to add my temp value to this. And write it back into corners. So we just told Blender, hey, you know our corners attribute, take that and add this temp value, which is this corner here, and just write it in there, add it onto our little corners attribute. And now I'm going to duplicate this math node, and instead of our intersection between the top and the right wall, perhaps now we take a look at the right wall and the bottom wall, which should give us the next corner. And yet again, our result will be called temp, and this is going to override this temp value that we declared earlier. I'm just going to duplicate this node over here, and as you can see, the second corner appeared, so we don't have to change anything here. Let's take this, and now we're going to take a look at the intersection of the bottom wall and the left wall. So left wall, and we're going to add it into the calculation. Now this wall appeared. Now I'm going to duplicate this again. And now the only thing left to do is the intersection between left wall and top wall. And now we add this to our corners value as well. And congratulations, we now got our 4 corners. So the last obvious thing we have to do is replace our sphere with an actual model. I'm going to duplicate our little window model here, and I will add some windows here. See, it's actually a corner, and I will replace the sphere with the model we just made. If something looks a little bit weird still for you, make sure that this corner is rotated in the right way. Essentially that your windows that you just added are on the right side. If this would be rotated, I don't know, 90 degrees on the Z-axis like this, and this wall would look in that direction, and I now apply the rotation, it would look like this, and you would think, huh, that still looks wrong, that still looks the same like before. Well, just because your corner piece is rotated the wrong way. So try to keep an eye on that. And also take note that we actually didn't have to do any additional math to rotate it the right way, because this is something we already took care of in the last video. Because we worked clean, we have less work to do now. Next up, I want to have a ground floor. Most buildings, especially high-rises, have something different going on the ground floor. There are storefronts or entrances, so we're going to need another point separate node. And this time I'm going to call the mask ground floor. And I will put it here before I separate out the corners perhaps. And the way we find this ground floor is similar how we found those 4 different walls. We are going to take an attribute compare node, plug it in here. We are taking our pos z value, which is the position of all our points on the z-axis, which points upwards, which is the way we want. I'm going to compare it to a float value, and instead of greater or less than this time, I will choose equal. And by default, it will put in a 0 here. And now I want to write the result of our little calculation into ground floor. And essentially we just told Blender, hey, take a look at all of our little points that we have here, and all of the points that are on the z-axis position of 0, mask them out and put them into this ground floor value. So the only thing left to do is get ourselves another model and I will take another point instance node, duplicate it, choose our newly made model here, plug geometry 2 into it, which is our ground floor, and join the geometry. And I know what you're thinking, the corners do look wrong again, but no reason to despair. All the calculation we did beforehand was not for nothing, because it actually carries over into both of these branches. So I can just duplicate this point separate node here and put it down here where we have the ground floors and just separate the corners yet again. And as you can see, it works for the ground floors as well. Well, we're going to need another model though, so I'm just going to duplicate it over here. And now, if I yet again duplicate this point instance node, I can put in the geometry here and plug it into join geometry and select our newly made object. And now, as you can see, we actually have a different looking ground floor. We have corners, we have walls. Now I'm going to show you one last thing. As you can see, I've created this very primitive and stupid looking entrance here, and I will take this entrance and I will take the other straight wall because they kind of fall into the same category. I'll press M and make them into a new collection, which I'm going to call ground floor straight walls. And I've also renamed them just for cleanliness sake. And instead of the object ground floor straight, I'm going to select a collection, and I will select the collection we just created, ground floor straight walls. And instead of whole collection, I will just deselect it, and now it will randomly choose an object out of this collection. And that's a quick way to add some detail, I think. And another thing that you could do then is get yourself another group input and just take this collection and plug it in here, which will create this input, which we could rename to something like GF for ground floor straight walls. And if in the far distant future your node group is ready and you want to have different building styles available, you can just build a couple preset collections and toggle through them using this input that we've just created. So that's it for now. Let me know what you think. Put questions in the comments if you got them, and I'm looking forward to the next tutorial. Hope you had fun and have a great evening.